Hey everyone, welcome to your YouTube homework review. It's Mr. Sarley, and we're on our next packet to help us review for the state test. This packet covers pretty much everything, but the main focus is going to be reviewing proportional relationships. So let's quickly review that. So just as a reminder of what proportional relationships are, those are relationships that have the same unit rate. Another way of thinking about them is that they're constant. The change is always the same. Um, so we're almost looking for relationships that have a very predictable pattern. So here's two tables. Let's figure out which one shows a proportional relationship. They both involve a walking rate, one with Team A and one with Team B. If you look at Team A's, there's a very obvious pattern that's showing up. You see that every single time you can take the hours and multiply them by 3, and it's going to equal the distance in miles. And that works for any value in the table. And if you look at Team B, if you tried looking for a relationship between time and distance, you might think that, okay, 1 times 2 equals 2, but then for this one you'd have to do 2 times 3, and for this one you can't even multiply it without getting some crazy fraction or decimal. So we would say that the team that has a proportional relationship is Team A. And a couple ways you could say why. One, you could say they have a constant unit rate. In this case, the unit rate is 3 miles per hour. And that rate is constant. Another way to think about it is each one of the ratios in the table can be simplified to the same unit rate, right? So that's the same as 1 to 3. If you take a look at another one in the table, just picking another ratio, this is the exact same, or is equivalent to 1 to 3. So there's a constant pattern in Team A. And then for this one, I just kind of showed you already. If you start looking for a pattern, you see that it's not constant. There's not a constant relationship. So that's how we know that Team B is not showing a proportional relationship. All right. So one of the main things about proportional relationships is they're so predictable you can write a rule in the form of an equation that works for any values in the table. So if we look at Team A, remember I said that the unit rate, also known as the constant of proportionality, is 3. And what we're doing each time is we're taking the time, multiplying it by 3, and it's equal to the distance. You might also see this written as 3t equals distance, which means the same thing, or distance equals 3t. Any of those would have been correct. D says show that your equation works for different ratios in the table. So I'm going to take this form of the equation, and I'm going to go to one we haven't talked about yet, this ratio of 4 to 12, where this number is the time and this number is the distance. And then what I'm going to do is I'm going to show that it works by substituting in 4 for t. And when we do that, we get 12, which is equal to the distance. So that's one way to show that this equation works for any values in the table. All right, Elizabeth types at a constant rate of 40 words per minute. So this problem is giving us the unit rate because it's 40 words per 1, which is what the unit rate is. Remember that the unit rate is also known as the constant of proportionality. All right, so if we use that unit rate in 1 minute, Elizabeth will type 40 words. In 2 minutes, she'll type 80. In 3 minutes, she'll type 120. But then be careful here. You might be like, oh, it's just always going by 40. But the next thing they ask about is 6 minutes. And 6 times 40 is 240. And I wonder if any of you connected it to our percent unit and just noticed this. And then 60 minutes, that's basically just going to be the same as before, but with an extra 0, because you could have thought about it like multiplying by 10, or you could have just done 60 times 40 equals 200 or 2,400. All right, and then for the equation, well, the 40 words per minute works every time, right? You can take the number of minutes, multiply it by 40, and it will always give you the number of words. Just showing you how this works everywhere in the table. So that means that it's going to be 40 times the number of minutes is equal to the number of words. Kennedy's makes $12 for each pizza pie it sells. Create a table to represent this relationship. All right, so now our constant of proportionality, or our unit rate, is 12. So if Kennedy sells one pizza, they're going to earn $12, and you could have thought about that as just 1 times 12. 3 pizzas times $12 per pizza would be $36. 6 pizzas times $12 per pizza is $72, and 10 pizzas would be $120. So the equation of proportional relationship always has the unit rate, or the constant of proportionality. It's always going to be multiplying by one of the variables, in this case by the number of pizzas, and then it's going to equal the other variable, which in this case, let's say E, for the amount that they earn. All right, and last one for part A. Irina read 3 books last month. The table shows the number of pages in each book and the length of time it took to read the entire book. All right, so it's asking us to write an equation, and to do that we're going to have to find the unit rate. And notice that the table's a little tricky because we don't know how much Irina reads per hour. But the thing is, to find the unit rate, you can divide. So I'm just going to take the first ratio in the table, and I'm going to take the number of pages, 208, and divide it by 8 hours. And when I do that, it's going to give me how much she reads in 1 hour. And I guess a way to think about it is if you have pages and hours, and you have 208 pages in 8 hours, when we're dividing by 8, that's helping us find 1 hour. So that's one reason why you can use division to find the unit rate. It's like you're finding an equivalent ratio. All right, so doing this division, 8 doesn't go into 2. Some people like to stick a 0 there. 8 goes into 20 twice. 8 times 2 is 16. Bring down the last place value. 8 goes into 48 6 times, and we don't have any remainder. So the unit rate in this problem is 26 pages per hour, and you could even check it, but the idea is we can multiply the number of pages by 26 each time. Ugh, no, that's not the idea. That number would be huge. You take the number of hours and you multiply them by 26, and it equals the number of pages each time. Okay, so to put that in equation form, we have the unit rate, which is the number of pages read per hour, so multiplied by the number of hours, and that's going to equal P, the number of pages Irina reads. Alright guys, and for the secret word for this week's packet, I'm actually not going to use words, I'm going to use emojis, and I'm going to start off with the one that I think is probably the most popular emoji there is. Feel free to argue with me, but good luck drawing this, unless your name is Carla, in which case You're going to put us all to shame with your awesome drawing.